Hello, and welcome to SR Experts Tech Talks. My name is Mike Mangino, and I work for Nokia's Network Infrastructure Division. We're here to talk technology today with our experts. And as usual, if you have any questions after the talk, feel free to reach out to your Nokia representative.
My name is Rudy Hoebeke, and I run product management for our IP business at Nokia. How you optimize the introduction of 400 gig transport services is very quickly becoming an important consideration in many service provider networks, driven by the need for more capacity at a lower cost per bit. From a router perspective, 400 gigabit Ethernet has been the new currency for port speeds for a while now. The number of 400 gig QSFP-DD based assemblies we are shipping is accelerating very fast. And 800 gigabit Ethernet is becoming available and supported on FP5 based assemblies. Early adopters already have the opportunity to pave the way towards 800 gigabit Ethernet. But equally interesting is the market shift that is happening with respect to transport services at 400 gig speeds now and 800 gig speeds a few years from now. Compact, router pluggable, coherent 400 gig DCO optics are now available that bring interesting options to optimize IP-optical networking designs. And this evolution in 400 gig transport services is possible because of advances in coherent DSPs that led to the introduction of those 400 gig ZR and ZR Plus optics. Traditionally, as you know, coherent optics have been quite far behind gray optics in terms of achievable router blade densities, given the size of those optics, given the power requirements for those optics. And that has historically made the integration of coherent optics in routers always less favorable. That is now changing with 400 gig ZR, ZR Plus optics that you can get in the same QSFP-DD form factor that is used for its short reach gray counterparts. You can now mix and match 400 gig short reach gray optics and 400 gig long reach ZR, ZR Plus optics on a router blade without density trade-offs. Of course, assuming that these routers were designed from day one to allow these to be powered and cooled in every cage, as is the case for our 7750 service routers. This represents a very important shift in transport, right? From the 100 gig era where most deployments relied on external transponders for long reach transport and for muxing 100 gig interfaces into higher speed wavelengths, which is more efficient, to a 400 gig era where these are now complemented with router pluggable 400 gig coherent optics that can close longer reaches directly over a simplified optical line system. And this offers some very interesting options to rethink and re-optimize metro and regional networks as we move into the 400 gig transport era. 400 gig ZR allows 40 kilometer unamplified connectivity between routers. And with an optical line system, 400 gig ZR provides support for 120 kilometers amplified connections, and 400 gig ZR Plus can even support distances up to 450 to 500 kilometers. And for those slightly longer distances, all the way up to maybe 750 kilometers, you can have the option to use router pluggable 400 gig CFP2 DCO multi-hall optics with a higher power budget. And they come at a bit of a density trade-off, of course, but in many deployments, you will see that these are useful to bridge these longer spans. And in many deployments, you will see a mix of these transport technologies, of course, complemented with traditional 400 gig high-performance any-distance coherent optics that go on dedicated optical transponders that can really span thousands of kilometers. At Nokia IP and Optical, we did quite a bit of work to be ready to support you in this journey towards 400 gig transport with optimized solutions. First of all, from the router side, all QSFP-DD cards on the SRS, DSR, the XRS products support 400 gig ZR and ZR Plus optics. We provide the support without compromise, as I said, right? These systems, these assemblies were designed from day one to provide sufficient cooling and power capacity to each slot and each cage to allow ZR Plus without restrictions, without density trade-offs. And we are definitely unique in that capability. And we also have CFP2 DCO cards, XMAs and MDAs on all these platforms that support 400 gig CFP2 DCO optics to handle those longer distances where needed, allowing you to cover a larger set of use cases without having to rely on external transponders. And as I mentioned earlier in my presentation, Coherent 400 gig pluggable support extends now beyond the SR portfolio. We are also supporting ZR and ZR Plus QSFP-DD optics and even 400 gig CFP2 DCO optics on various 7250 IXR products, which will of course be very useful in mobile transport applications and in many aggregation networks. Now on the optics side, quite some innovation as well. I'm actually very happy to announce that we have extended our traditional portfolio of optical WDM systems with a 400 gig ZR Plus optimized optical line system called the PSI-CL. This optimized optical line system provides all that is needed in most of the use cases where ZR Plus router pluggable optics make sense. And it does that in a cost-optimized and a compact form factor. It provides inline amplification, of course, to extend the reach beyond a single span. It provides a fixed WDM multiplexing capability to efficiently groom multiple wavelengths. It provides 1+1 fiber protection, if that is something that you desire in your network. And it provides a 2-degree ROADM capability as well for router bypass in simple wavelength topologies. And it can be managed directly through NetConfiang by NSP. So it allows you to do the provisioning and the assurance across IP and optical systems from a single management system. The use cases for these router pluggable Coherent 400 gig DCO optics and this optimized optical line system are plenty in access networks, in metro networks, and in regional networks. Think of direct router interconnect applications in the metro or in backhaul environments or between data centers, a DCI style application. These are obvious use cases. This can be done over dark fiber in some cases if the span is less than 40 kilometers, or you can use this optimized optical line system for amplification and WDM multiplexing when a longer span and more capacity is needed between those sites. And with router bypass in simple topologies like rings using its 2-degree ROADM capabilities, we offer you the next level of flexibility. When used appropriately for the right use cases, this will lead to an optimized TCO versus the traditional deployment model with external transponders. That being said, obviously this isn't the most optimized solution for all use cases, as another router vendor would like you to believe. In general, when longer spans are involved or when the wavelength complexity becomes more complex, then it is less straightforward, and this needs careful analysis, and experience shows that the lowest total cost of ownership in these cases will often require a mix of the various tools that we are providing. To illustrate this on this slide, a simple example of a metro network of a large tier 1 service provider we worked with 4 metro core sites, 42 edge sites which are groomed into those core sites in a fairly large metro environment. We worked with this customer to seek the lowest TCO solution to upgrade this to 400 gig connectivity between some of those edge locations and core locations and between the core sites, obviously. We modeled a variety of deployment options, out of which I'm just highlighting 2 on this slide. The most optimized one and the one that is actually triggering most debate in the industry today. The latter one is the one where you exclusively rely on router integrated coherent optics and you build this network using hop-by-hop routing only. The first one is the most optimized design in this case, is where you combine pluggable coherent optics in routers for those moderate spans where it makes sense with ROADM-enabled optical line systems to provide efficient bypass of intermediate hops where that is possible, or in order to avoid the need for the introduction of an intermediate router hop to regenerate the signal. This is a case where turning this network into a hop-by-hop router network would have resulted in a significantly higher total cost of ownership. One simple metric of this is shown here, which shows that you need a lot more coherent pluggable optics and thus router ports in a hop-by-hop design. A balanced view is important. There isn't one approach that is optimized for all network designs and all use cases. With the developments we've done, we're confident that we have all the tools across our routing and optical portfolio to bring you into that 400 gig transport era with the lowest total cost of ownership. We support 400 gig coherent ZR and ZR Plus optics across our service router portfolio without compromises, and we have extended this to the IXR family as well. And we also provide 400 gig CFP2 DCO pluggable options across our SR and IXR portfolio as well to close those longer distances. As we discussed, we also now have a 400 gig ZR Plus optimized optical line system in the PCI-CL that will be applicable in many ZR Plus use cases in access and in metro networks. It's simple, it's compact, it's cost optimized, and it's directly integrated into NSP. And we have our 400 gig long-haul transponders and multi-degree ROADMs to complement this when longer spans and complex wavelength topologies are involved. And of course, our consulting engineering teams are also ready. They have the expertise and the experience to help you with this modeling and come up with the best recommendations, the lowest total cost of ownership options for your network.